Welcome to A1 Tutor Live class. Today we are going to be considering our first topic for the live class in mathematics, and that is number base. Number base. Number base is a topic in mathematics that needs to be treated with utmost attention. Now, how does number base work? Let's consider an illustration to introduce the topic. While we are still in primary class then, if you can remember, we mostly do some basic operations in mathematics, the likes of addition, subtraction, multiplication, and division. Now, if you remember very well then, our teachers taught us that when we have 12 minus 7, if you are to evaluate this in this approach, if you are to evaluate this expression, then we are taught that you have to borrow 1 from this. This will be left as 0, and this will change to 12. How is that possible? That is where we bring in the topic number base. What we are not told then was that we are not borrowing 1, but we are borrowing 10. Why? Because any number written in mathematics without any base is said to be a number in base 10. So what we have borrowed here is not 1, but 10. And 10 added to the 2 we have initially will give us the 12. Will give us the 12. And that is a basic operation in base 10. What of if we are adding 1 plus 1? Literally, the answer should be 2. But in some cases, you'll be told that the answer is 10. How is that possible? Of course, 1 plus 1 is 2, and that is because we are working in base 10. And also, 1 plus 1 is 1, 0. Why? Because in this case, we are no more working in base 10, but we are working in base 2. And base 2 allows just 2 digits, and that is the 0 and 1. And that is what we call binary. The computer system we use has been configured using binary system, and it allows only the language 0 and 1. So this is the basic thing we have to know about the introduction aspect of number base. There are more tips we have to consider as we go into the class proper. Now let's proceed into the topic proper. What are the tips we need to know concerning basic operation in number base? Basic operation in number base. Basic tips in number base. Now, there are some things we need to consider when working under number base. Number one, a number expressed in a base, all the digits have to be less than the base. A number expressed in a base, all digits must be less than the base. We have a number 10101. Of course, this number can be in base 2 or base 3 or base 4 or base 5 up to base 9. Take note, all the digits in this number are less than the base. The base is 2, and all we have here is 0 and 1. So a number expressed in a base, all the digits in the number have to be less than the base. 4876. If we are asked to suggest the base for this number, what would be the appropriate response? Of course, the answer would be 9. Why? Because the digits 4, 8, 7, 6 are all less than the base, which is 9. So you have to take note of that all number expressed in a particular base or a certain base have to be less than the base. That's the first tip. The second tip. We can only add and subtract number of the same base. We can only add and subtract, also divide and multiply number of the same base. We can only perform this basic operation: addition, subtraction, division, and multiplication for numbers that have the same base. For instance, we have this illustration. We have 4, 2, 6, base 7, and we have 3, 6, 5, base 7, and we have another one here, 3, 4, 5, base 6, and we have 4, 3, 5, base 8. Now, the first example and the second example of number we have here, for this, we have base 7, base 7. That is, we can perform all the basic operation between these two numbers. We can add, we can subtract, we can multiply, and we can also divide. And the reason is because they have the same base, 7 and 7. For the second number we have here, this is expressed in base 6, and this is expressed in base 8. For these two numbers, we cannot add, subtract, divide, or multiply. Why? Because we have base 6 and we have base 8. They are different bases. So for us to perform the basic operation in number base, the base of the numbers have to be the same. The base of the number have to be the same. That's the second tip. The third tip. When you are performing basic operation in a particular base and you are to borrow a value, the value you borrow represents the base. Numbers borrowed while subtracting in a particular base is equivalent to the base. The number borrowed while subtracting in a particular base is equivalent to the base. Let's cite an instance. We have 4, 3, 4 in base 5, and we have 4, 4 also in base 5. And we want to perform subtraction. Of course, we are working under base 5. And if we are to subtract 4 from 4, this will give us 0. Take note, we are working in base 5. Now we want to subtract 4 from 3. That is in this way. 3 is lesser than 4, which means to subtract will not be easy, or it will not be possible, except the number we are subtracting from is bigger than 4. So what do? We borrow from this. This will be left as 3. And what we have borrowed is not 1, but is equivalent to the base we are working with. So what we've borrowed is 5. And that will be 5 added to the 3 we have initially, and that will be 8. So the new value we have now is 8. Then we can proceed to subtract 4 from 8, and that will give us 4. And the last value we have here, since we have nothing to subtract from 3, we have 3 back. And the answer will be 3, 4, 0, base 5. And you can see that the final answer are all less than the base. They are all numbers that are less than the base. The base is 5, and we have 3, 4, 0. They are all lesser than 5. So the number we borrowed while subtracting is equivalent to the base we are working with. The next tip. The next tip. In conversion of a base from one base to another base, when we are converting a base to another base, we have two ways of doing that. Either we are converting a binary to a base 10, or converting a binary to another base, or converting base 10 to binary. But before we dive into that, we have to know the common basis we have. The common basis we have in number base. We have binary, which is also known as base 2. It uses 0 and 1. We have decimal, also known as denary, is called base 10, and it uses values from 0 to 9. We have octal, also known as base 8, and it uses value from 0 to 7. So these are the common bases we have in mathematics. We also have hexadecimal, but for this class, we'll be considering these 3 particular ones, and other bases like base 7, base 3, base 4. Now, how do I convert a number from binary to denary? Conversion of a number from binary to denary. Binary to denary. Now, how do we convert number from binary to denary? We are converting a number in base 10, in base 2 to base 10. And what we use is what we call the multiplicative and exponentive approach. Multiplicative and power approach. That is, we have 1, 0, 1, 0 in base 2 to be converted to base 10. The approach we'll be using is what I call multiplicative and power approach. Now, for us to do this effectively, we have to give power to all of the digits present in this number, starting from the back. So we have 0, always start with 0, 1, 2, 3. That is the power approach. Now, the multiplicative approach is by multiplying each of these digits 1, 0, 1, 0 by the base. Multiplying each of these digits by the base. Let's proceed. 1 multiply, the base is 2, multiply by 2, open and close the brackets, and the first number we used was 1, and the power on it is what? 3. The power will be on the base. Now the second one is 2, but notice it is 0. To save time while solving and to work smartly, you do not consider the digit that is 0. So we can cross out this and move to the next one. Plus, the next one is 1 multiplied by 2, and the power is what? 1. So we have raised to power 1. And for this also, the digit is 0. So we may not consider this also. Cross it out. So what we have is 1 multiplied by 2 raised to the power of 3. 2 raised to the power of 3 is 2 multiplied by 2 multiplied by 2, and that is 8. So we have 8, close the bracket, and we have 1 multiplied by 2, that will give us 2. 1 multiplied by 8 is 8 plus 2, and we have 10, expressed in what? In base 10. So we have successfully converted this value to base 10 using the power and multiplicative approach. Why do I call it power? It is always expected that you give power to your digits, and also it is expected that you multiply your base with every digit present in the number, and you round it up by adding each of your value. Now, what of converting from base 10 to base 2? From base 10 to base 2. How do we go about that? Converting from base 10 to base 2. To convert a number from base 10 to base 2, we use the division approach, the long division approach. With the long division approach. So we are going to be dividing the number given by base 2. Let's cite an example. We have 35 is in base 10. We have to convert this to binary, and that is base 2. And I said we are going to be using the long division approach by using a table. Using a table, we are dividing by 2 because we are converting to binary. We have 35. Then add another column for remainder, because what we'll be dealing mostly here, we'll be considering the remainder while dividing. So we have to divide 35 by 2. And let's start with the first digit. Divide 3 by 2, we have 1. And out of that, we have 1 left. So we have 15 now. Divide 15 by 2, that's 7. And the remainder is 1. We continue using 2. Divide 17 by 2, that will be 8. And the remainder is 1. Again, 2. Divide 8 by 2, the answer is 4, and the remainder is 0. Divide 4 by 2, we have 2, and the remainder is 0. Divide these 2 also by 2, we have 1, and the remainder is 0. Now, do we have to stop here? No. We have to continue until we get the impossible response. And what is the impossible response? When we are dividing the number by 2 and it's not possible, then the last step will be after that step. We have 2, we have 1 here, and we go again for the last time. Divide this 1 by 2, which is not possible. So in that sense, the impossible response means 0. The impossible response means 0. So what will happen to the part of the remainder? We bring what we have here down to this place, 1. So the remainder will be any value we have here, we serve as the remainder. We said 1 divided by 2 is impossible, that is 0. And the remainder is the value we have here, and we have 1 as the remainder under base 2. For other bases, the same thing is applicable. You always have to take the last value here to be the remainder when you have reached the impossible aspect of dividing your values. So this is the way we convert base 10 to base 2. Now, let's consider some applications of all these tips in JAMB question. We're going to consider a few questions on how to apply all these tips to the question. Now let's consider a question. We are asked to evaluate, the first question, evaluate 3310 base 5 minus 1442 base 5. You need to understand the question before you proceed to solve. Evaluate this minus this. So we are working under basic operation in binary. We are working under basic operation in number-based system. Under basic operation in number-based system. And the operation to perform is minus. So we have 3, 3, 1, 0, 5. That's the base. And 1, we have to start from the back. 2, 4, 4, then 1, base 5. Subtraction. Take notes, the two numbers we are working with are all in base 5. So it is possible that we do the subtraction. And take notes, we are working in base 5. So if peradventure we are to borrow a number, the number will be in base 5. We have to take 2 away from 0. And that is not possible. 0 is lesser than 2. So we have to take from this place, borrow a value, and what we are borrowing is 5. If I borrow a value from here, this will be left as 0, and this becomes 5. Let me take this away. Then we have 5. We are taking away 2 from 5. The answer will be 3 base 5. Now we have 0. I want to take away 4 from 0. 4 from 0. That also is not possible. So we have to cancel this, borrow from this guy. This is left with 2, and this becomes 5. Take away 4 from 5. We have 1. Now we want to take away 4 from 2. That also is not possible. So we need to move to the next number beside it. Take away a number from here, and that will represent 5. This will be left with 2. This, you add to what we have here before, 5. That's 2 plus 5. We have 7. So the value we have here is 7. The value we have here is 7. So we are taking away 4 from 7. 4 from 7. That will give us 3. And here, we want to take away 1 from 2. That will give us 1. So the answer is 1, 3, 1, 3, base 5. How will you be sure that you are correct? Of course, check. The values are less than the base. The value are less than the base. So this will be the answer for this question. Let's consider another question. Question 2. Still under basic operation. Still under basic operation. We have evaluate 1, 0, 1, 1, 1 base 2, 1, 0, 1, 0 base 2. We're asked to evaluate this, and the operation here is plus. The operation is plus. We write the first number 1, 0, 1, 1, 1 base 2 plus the second number. Always start from the back. We have 0, that's the first number from the back, then 1, 0, 1 base 2. And we want to add this. Before we proceed with the addition of this, take notes. These key information are needed while adding in binary. 1 plus 0 in binary is 1. 1 plus 1 in binary is 1, 0. 1 plus 1 plus 1 is 1, 1 in binary. 1 plus 1 plus 1 plus 1 is 1, 0, 0 in binary. And we are going to be working with these basic keys while adding in binary. So the first thing to add here is 1 plus 0. And from the key, we have the answer to be 1. The next is 1 plus 1. 1 plus 1 is 1, 0. So what do? Do we write the whole number as 1, 0? Of course, we don't do that. You have to write a number and keep the next number for the next operation. So if we have 1, 0 as the answer, we write down 0 and take this to the next operation. So we write 0 down, then to the next operation, we keep 1. 1 plus 1 plus 0. 1 plus 1 plus 0. We still amount to this, 1, 0. You write 0 down, and you keep the 1 to the next operation, 1. 1 plus 0 plus 1 will also give us 1, 0. Write 0 down and keep 1 to the next operation. So we have 0 and we'll keep 1 here. Now, this is the last operation we want to do. So any answer we have will be written down in full. 1 plus 1 is 1, 0. And we have to write it as 1, 0. We have to write everything down because we have no other numbers to add again. We have no other digits to add. And the answer is 100,001 base 2. 100,001 base 2. So this is the way we had in binary. Let's consider two more questions under UTME that are not under basic operation. So we have question 3 to solve now. Solve for the value of R. In this expression, 6R 7 base 8 is equals to 511 base 9. 6R 7 base 8 is equals to 511 base 9. So we want to obtain the value of R. That's the question. Solution. Six R 7 base 8 is equals to 511 base 9. Now, when you look at this question, we have base 8, base 9. They are different bases. Base 8, base 9. And for us to obtain the value of R, both sides have to have the same base. Both sides have to have the same base. And for that reason, we need to convert this to base 10 and also convert this to base 10. Then we'll be able to obtain the value of R. We know how to go about converting to base 10. It is using the power and multiplicative approach. So what do we do? Give power to this 0, 1, 2. For this also 0, 1, 2. Open your bracket. 6 will multiply the base, that is 8, and it is raised to the power of what? 2. The base is raised to power 2. We have 2, close the bracket, plus the next one is R multiplied by 8, which is the base, and the power is 1. We have raised to power 1, plus the next one is 7 times the base 8, and the power is raised to the power of what? 0, 0. Close the bracket. Let's simplify this part first, then we'll move to the other parts. This is 6 multiplied by 8 squared. That is 8 multiplied by 8, and that will give us 64. We close the brackets, plus R multiplied by 8 raised to power 1. 8 raised to power 1 is also 8. So we have multiplied by 8 plus 7. 8 raised to the power of 0. From the law of indices, that any number, alphabet, raised to the power of 0 is 1. Any number, alphabet, raised to the power of 0 is 1. So 8 raised to power 0 will be 1. So we have multiplied by 1, close the brackets. Multiplying 6 times 64. 6 times 64, that's 64 times 6. That should give us 384 by normal multiplication. So we have 384 plus, multiply 8 and R together. R times 8 is 8R. We have 8R plus 7 times 1 is 7. So we can add this 7 to 384, but we cannot add 7 and 384 to 8R. So we can only add these together because they are constants. But this is an algebraic expression. It has a variable, R. So we can only add these together because they are the same family. They are just constants. So we have 384 plus 7, 11, 1, we keep 1, and this will give us 9, and this is 3. That is, we have 391 plus 8R. So we've done justice to this part. Now we want to consider this part. We have, for this part, we have 5 multiplied by the base, open bracket, 5 times the base is 9, and the power is 2. That is 9 raised to power 2, close the bracket, plus the next number is 1. 1 multiplied by the base, which is 9, and the power is 1. So we have 9 raised to power 1, close the brackets, plus, open the brackets. The next number is 1. 1 multiplied by 9, raised to the power of what? 0. Raised to power 0. So we have, open the bracket, 5 times 8, 9 raised to the power of 2 is 9 times 9. That's 81. 81 plus 1 multiplied by 9 plus 1 multiplied by 9 raised to the power of 0 is 1. So we have 5 multiplied by 81. That's 81 multiplied by 5. 81 multiplied by 5. That should give us 81 multiplied by 5 plus 1 multiplied by 9 plus 1 multiplied by 1. We have 81 multiplied by 5, that's 405 plus, this will give us 9 plus 1. So we can simplify this. 405 plus this added together should give us 10. So we have 514. So for the simplification of this, we have 415. Now we are going to equate this answer to what we got earlier. What we got earlier was 391 plus 8R is equals to the other side, which is 415. By simple collection of like terms, this is positive. Moving to the other side, we have it as negative. 8R will now be equals to 415 minus 391. 8R equals to, subtracting 415, take away 391, minus, take away this, we have 4. This adds to it, that is 11. Take away 9 from 11, that's 2. And this becomes 3 minus 3 is 0. So we have 24. We have to divide both sides by the coefficient of 8, by the coefficient of R. And the coefficient of R is plus 8. The coefficient of R is plus 8. So we have 8R divided by 8 equals to 24 divided by 8. 8 we cancel 8. R equals to 24 divided by 8 is 3. 24 divided by 8 is 3, which implies that the value of R in that question that was given earlier is 3. The value of R is 3. So this is the way we solve to get the value of a particular variable in number base. Sometimes you can be asked to find X, it can be Y, it can be any alphabet, exception of O, I. These two letters are not mostly used in mathematics to avoid confusion. So this, our answer is 3. R equals to 3. If you check back the question, we had 6R7 base 8. So if I'm to plug in the value of R, I'll be having 6, 3, 7. The space of R will now be 3, 7 base 8. And these 3, 6, and 7 are all lesser than the base, which is 8. So you have to take note of the answer you are getting. Is the answer lesser than the base? 3 is lesser than the base. So 3 equals to R is the response for the value of R. Okay, we'll take one more question, then we'll move to evaluation aspects, where we'll be having some questions to ask each other on what we have done so far today. Evaluate 101 base 2 all square. This is a question for us to do. Evaluate 101 base 2 all square. We have to evaluate this. And from your knowledge of indices, a square is a multiplied by a, which implies that this question is the same as 101 base 2 multiplied by 101 base 2. It will appear twice by multiplicative sign because of the power. So we have to multiply 101 base 2 and 101 base 2. Okay, we have some students raising up their hand here. Let's pen this and attend to their question. Okay, let's quickly round up this aspect of question. Then we'll move to the aspect of answering a question. We have multiplying this. We have 1, 0, 1. Multiply with the first digit. The next digit is 0. We have 0, 0, 0. Multiply with this. We have 1, 0, 1. And what we have left to do is to add together. They are all in base 2. So the first one will give us 1. Adding 0 to 0, we have 0. 1 to 1, we have 0. And we keep 1 on the next value. And we have 1. And this has nothing to add to. And this also comes down as 1. And the final answer will be 1, 1, 0, 0, 1 base 2. Now, do we have any one of us that have question? You can signify by raising up your hand. Questions? Any question? Okay. If there are no questions, let's quickly do a brief recap and evaluation of what we've done today. Today, we've touched the tips of basic operation in binary. We've touched the tips of basic operation in number-based system. And the basic operation we discuss is plus, minus, multiplication, and also division. These are the basic operations that can be performed in binary. We also made mention that numbers can be multiplied, added, divided, or subtracted when they have the same base, then we can perform the basic operation. We also touch conversion from base 2 to base 10, and also from base 10 to base 2. For more explanatory videos, kindly check on your A1 Tutor app. There are videos lessons there that will explain more details of all we've discussed today. And also for practice question, kindly also visit the app. There are CBT questions that have been put in place for you to practice, both for UTME and O-level exams. Do well to practice those questions and have also a feedback by having explanation to your questions when you are almost closer to the answer. So please do well, check for the videos on number-based system to have more deep knowledge on the topic. Thank you for your time today. We really appreciate, and always ensure that you do not miss any of our live classes. Through this, you are going to come out excellently in your UTME. Also, take notes, our next class will be coming up today, and that's the English class. Ensure you also join for the live session of the English class today. Tell your friends to also be available for these live classes. See you in the English session class.